All right, today we're going to talk about something fascinating. We're diving headfirst into the fiery and, well, pretty flawed world of how we recycle our electronics. It's a story that involved incredible heat, hidden treasure, and some really, really tough choices. Think about it. We've all got that drawer, right? The one with the old phones, that forgotten laptop, a whole nest of tangled chargers. But when you finally clear it out, where does all that stuff actually go? It's so easy to just imagine it disappears somewhere, but the reality, it's way more complex and honestly a lot more interesting. All that stuff becomes part of a massive global challenge. And that brings us to our first point, our e-waste mountain. And when I say massive, I mean it. This is a problem that just keeps growing every single day with every new gadget we all buy. Now, this mountain of e-waste is a really interesting paradox. On one hand, of course, it's a huge environmental headache. But on the other hand, hidden inside all those circuit boards and wires is this incredible resource, what some people call a literal urban mine. It is packed with gold, palladium, copper, all sorts of valuable metals. So, the big question is, how do we get those valuable materials out of that mountain of junk? Well, the industry's main answer is, pretty elemental. They use fire, a lot of it. The technical term for this whole process is pyrometallurgy. It sounds kind of complicated, but let's just break it down. Pyro means fire, and metallurgy is the science of metals. So it's literally the science of using crazy high temperatures to extract and purify metals from our old electronics. It's a very intense, almost brute force approach to recycling. And you gotta understand, this isn't some niche experimental thing, oh no. Pyrometallurgy is the industry standard. It's the dominant, time-tested method that facilities all over the world depend on to process the vast majority of our e-scrap. It really is the main event in e-waste recycling.
Okay, so what does this trial by fire actually look like? Let's go inside the smelter, so to speak, and see how all this high heat magic really happens.
It's basically a two-stage process. First up, you have what's called reductive smelting. This is where everything gets melted down in a furnace. The intense heat makes everything separate by density. So the heavier, valuable metals, they all sink down and form this alloy they call black copper. Meanwhile, all the lighter junk, the impurities, floats to the top as this glassy waste product called slag. Then you get to stage two, oxidative refining. This is where they take that black copper and purify it even more to pull out the really precious stuff like gold and palladium. And just to be clear, we're not talking about some simple bonfire here. This is seriously advanced industrial tech. They use these specialized furnaces that create a superheated, turbulent bath of molten material. The best way to picture it is like a violently churning cauldron, where all that constant motion speeds up the chemical reactions and just squeezes every last bit of precious metal out. So it all sounds pretty effective, doesn't it? A powerful way to mine our own waste. But this is where the story gets, well, complicated. This fiery solution comes with a major trade-off. And the trade-off is pretty stark when you lay it all out. I mean, on the one hand, pyrometallurgy is the king of the industry for a reason. It can handle huge volumes, even e-waste that doesn't have a lot of precious metals in it. But the costs? They are enormous. The process uses an incredible amount of energy. It creates other kinds of waste that then have to be managed. And the sheer heat and corrosive environment are constantly eating away at all the expensive equipment. It is a costly battle on every single front. So when you start to put all these pieces together, you really begin to see the full picture. Pyrometallurgy is without a doubt powerful, but it is far, far from a perfect solution. And look, this isn't just me saying this. It's a reality that's widely known within the industry itself. The general consensus is that even though this has been the main method for a long time, it has, and I'm quoting here, major drawbacks. So, in other words, the very foundation of how we recycle our e-waste has some serious cracks in it. And that, really, is the story of recycling with fire. It's this impressive, almost ancient solution to a very modern problem, right? We're using old-school metallurgy to deal with 21st century waste. But all that power comes at a very real cost, a heavy price we pay in energy, in secondary waste, and in cold hard cash. And that leaves us with a really critical question to think about. As our mountain of e-waste gets taller and taller every single day, can we really afford to keep relying on a solution that costs so much, environmentally and economically?
Or is it maybe time we started looking for a smarter, more sustainable way to mine our digital graveyard?